Next, we talk about the maximum shear stress. So just now, we talked about the principal stresses and the principal planes, and the method how to find the principal plane as well as the principal stress. So now let's talk about how to find the maximum shear stress. So notice that for principal stresses, it is just talking about the direct stress, but for the maximum shear stress, it is just maximum shear stress. It does not have some name like principal shear stress. No, there is no something like this. There is no something like this, okay? It is just maximum shear stress. Recall the transformation equation of the maximum shear stress. Then we take the derivative of it with respect to theta, still, just like what we did for the direct stress. Then you will get d tau d theta equals to minus 2 tau sine 2 theta minus sigma x minus sigma y cosine 2 theta. And we solve it when the derivative equals to 0. Then we have tangent 2 theta s equals to minus cotangent 2 theta p. What does that mean? So after solving the system, you will have minus 2 tau xy sine 2 theta equals to sigma x minus sigma y cosine 2 theta s. Okay, s. So theta s is just representing the maximum shear stress. Okay. Then by rearranging the terms, you can have tangent 2 theta s equals to minus sigma x minus sigma y divided by 2 tau xy. It just equals to minus sigma x minus sigma y divided by 2 over tau xy. Let's compare this result with what we have got just now. Just now, we got tangent 2 theta p equals to tau xy divided by sigma x minus sigma y divided by 2. Now we have tangent 2 theta s equals to minus sigma x minus sigma y divided by 2 divided by tau xy. Immediately, you can find the relationship that tangent 2 theta p equals to minus cotangent 2 theta s. Because you can observe from them, you can get this relationship. Tangent 2 theta p equals to minus cotangent 2 theta s. We can still write in this form. Tangent 2 theta s equals to minus cotangent 2 theta p. By the trigonometric relationship, we know that tangent x equals to minus cotangent x plus minus pi over 2. Therefore, we have 2 theta s equals to 2 theta p plus minus pi over 2. Then theta s equals to theta p plus minus pi over 4. So it is the relationship between the angle of inclination where the maximum shear stress occurs and the principal plane angle of inclination. So we make it clear. Theta s is the angle which maximum shear stress occurs, while theta p is the angle which represents the maximum direct stress occurs. And for theta p, it also has another name called principal angle. The plane with such a kind of principal angle is called the principal plane. So this equation just describes the relationship between theta s and theta p. After we getting the relationship between theta s and theta p, then we can find the maximum shear stress. Still, this is theta p, okay? All things are just very similar, except we add pi over 2 after the 2 theta p term, such that we can find the maximum shear stress. Still, remember that cosine x plus pi over 2 equals to minus sine x. Cosine x minus pi over 2 equals to sine x. Then we get cosine x plus minus pi over 2 equals to minus plus sine x. Similarly, sine x plus pi over 2 equals to cosine x. Sine x minus pi over 2 equals to minus cosine x. Then we have sine x plus minus pi over 2 equals to plus minus cosine x. So here it will become minus plus sine 2 theta p. Here it will become plus minus cosine 2 theta p. But luckily there is a negative sign assigned here such that it will become minus plus. So eventually you can write both of the minus plus into the way of plus minus. Okay, then the maximum shear stress is given by tau x1 y1 theta s equals to plus minus tau xy sine 2 theta p plus minus sigma x minus sigma y divided by 2 cosine 2 theta p. So still we keep the plus minus sign here. We do the simplification by substituting sine 2 theta p and cosine 2 theta p into the expression. Also, by the similar procedure, we make r to be the common denominator such that we can make the numerator like this, and immediately you can find it is just r squared. Finally, you will get the result, which is plus minus r. Therefore, the maximum shear stress of a stress element is given by r. However, another important observation is that when you have a log of sigma 1 and sigma 2, you can find that both of the sigma x plus sigma y divided by 2 terms are the same. Both of them are the same, okay? But the difference is that the r is plus minus, okay? For sigma 2, it is negative. For sigma 1, it is positive. Therefore, we know that sigma 1 minus sigma 2 equals to 2r. Then sigma 1 minus sigma 2 divided by 2 equals to r. So the maximum shear stress equals to the difference of the two principal stresses divided by 2.